Nadie puede dudar que el clima está cambiando. Aumenta la temperatura, se derriten los hielos, puede subir el nivel del mar y las tormentas pueden ser más severas. Mucho de esto se debe al efecto humano y las consecuencias pueden ser tremendas. Por eso la ciencia lo tiene que estudiar, para entender de dónde venimos, cómo estamos y sobre todo hacia dónde vamos. El profesor Thomas Stoker es uno de los mayores referentes en cambio climático a nivel mundial y ha desarrollado modelos matemáticos y físicos para entender el cambio climático y también para proponer posibles soluciones. Hoy conversamos con Thomas Stoker, uno de los mayores referentes en cambio climático. Dr. Stoker, you're a physicist by training. How come a physicist becomes interested in climate? Is it that common, or did you have to have a specific road to get to climate research?
My road was from atmospheric science. Okay. I then switched to oceanic sciences, and these are the two most important components of the climate system, and therefore it's natural that if you want to combine the knowledge about how the atmosphere works physically and how the ocean works with the circulation and the different water masses around the globe, combining that, you arrive at climate almost spontaneously.
Yeah, that's true. But let's go further back. Let's go to the young Thomas in high school or even before that. Were you interested in science, physics, and specifically oceanographic science or atmospheric science, or did it come?
I think it came through mathematics. I was extremely interested in solving problems using mathematics. That was my most favorite subject in high school. And I like the mathematics that is applied in contrast to the more theoretical mathematics where you prove theorems. If you apply it to a system that you can actually observe, I think that's the deepest satisfaction.
You're right, yeah. And when did you first hear about climate change? As a student? Once you were already a researcher?
No, I think education on climate change starts very early in Switzerland.
Is that so?
We live in an environment that has been shaped by the last glacial cycle 20,000 years ago. So where I grew up in Zurich, you see today still the traces of the glaciers as they have come down the mountains during the last ice age and formed the landscape. And these are things that you get exposed to already at primary school. Then it goes on in geography, and I think that was the moment where I wanted to learn more about this subject in a quantitative manner, understand why, and not just describe things how they manifest themselves to us, but understand quantitatively.
But that applies to climate science in general. What about climate change? How recent is the notion of climate change in terms of general science, not for the specialist, but now everybody talks about it. Has that been going on for long, or would you say it's just a few decades?
As the quantitative modeling, for example, of atmospheric dynamics and of oceanic dynamics was developed in the late 60s, the scientists then started to ask questions about the coupling of the systems. And that leads you again from the more theoretical side to trying to understand climate and climate change. And certainly the understanding that the concentration of greenhouse gases in the atmosphere has a direct impact on the climate system has been known for more than 200 years with the specialist, but then about 50 years ago people started to implement that into their models.
Now, you put it in simple terms, but I mean it's a chaotic system, so it's very difficult to predict. So how confident are you that we can really predict what's going on and what will happen being such a complex system?
I fully agree with you. It is a complex system, and beyond the physics, it actually is even more complex because we also have to understand the carbon cycle when you talk about carbon dioxide, the exchange between the atmosphere and the ocean. So you need to actually look at the coupled system of physics and biogeochemistry. So it's extremely complex. But some very basic considerations help us. The so-called conservation laws, which are a fundament of the scientific endeavor. I give you an example. You mentioned predictability. How can you predict or project into the future such a complex system of a scale that is our planet? An example is, take a pot of water. And we put that pot of water on a heating plate. Now you put number 2 on the heating plate. And you would probably agree with me that we are fairly sure of being able to predict the temperature of that pot of water after 5 minutes.
Yes, I would say so.
Why can we do that? Because we know what the heating plate at position 2 delivers in terms of power. We know the mass of the pot of water. We know the initial temperature. So we have an understanding of the initial condition of our physical system and combine that with the conservation law of energy and some considerations on radiation, etc. So we're very sure about our ability to predict the temperature in 5 or 10 minutes, given the heating rate. What we are unable to do in this same pot of water, when it starts to boil, to predict the location of a bubble of vapor as it forms from the bottom and rises up to the surface. We know that process is happening. We can estimate when it's happening, but we are unable to predict the precise location. That is because of chaos in this pot of water, but that does not prevent us from making an overall statement about the state of our boiling or of our heating, of our warmer water. And the same applies to the climate system. We are unable to predict the location and strength of a hurricane next year, but it doesn't prevent us from giving you a fairly good and accurate estimate of the temperature in the last 2 decades of the 21st century, given that we know the position of our heating plate.
Which we do because
and
it's
what
now.
is that? That is the scenario of emissions of greenhouse gases in the future, because those determine the heating rate in the course of the 21st century. So we need to know what position we put on our heating plate, and that means we need to know the scenario. But when we investigate future climate change, we always talk in various scenarios. What if I put number 1 on the boiler plate? What is if I put number 4 on my heating plate?
When people talk about greenhouse gases, the common idea is that the problem started with industrialization, and especially in the 20th century. But I've always thought about what happened in the past. I mean, we've changed the world much before the industry began. Actually, we started changing the world with agriculture. Wouldn't that be a starting point for climate change as well?
That's actually an excellent question, because it goes at the heart of the question, when did the Anthropocene start? A geological epoch that people are talking about. And certainly man has changed the Earth's surface through agriculture, through deforestation, etc. But these changes are still debated in the sense that, did they have a global influence on the carbon dioxide and methane concentrations in the atmosphere to the same or a similar extent as our use of fossil fuel and agricultural activities today do? So we see that small fluctuations did actually happen during the last 5,000 years, where you could say that man has started to change the landscape. But it's very difficult scientifically to attribute those changes precisely to man's activity. Whereas it's not difficult, it's still a scientific endeavor, but it has been accomplished to attribute the changes that we see today definitely to the two major influences, and that is the use of fossil fuels through the burning of coal, petrol and gas, and deforestation.
Okay, and the combination is probably terrible. When you don't get, you get more CO2 into the atmosphere and nowhere to trap it in, I guess that's the big problem.
Well, the CO2 is then, through the carbon cycle, redistributed in the compartments of the climate system, foremost the atmosphere, which we are using as a waste basket, if you permit that word, of human activity. That increased concentration then makes carbon dioxide penetrate into the ocean, which actually renders us a service of absorbing a significant amount of carbon dioxide. The price we are paying for that is ocean acidification. And so carbon dioxide has a far greater consequence on the entire climate system than just changing the energy balance in the atmosphere and therefore causing the warming that we observe worldwide.
I'm sure that the evidence towards the human influence on climate change is so overwhelming that there's no use in discussing it. But one of the arguments of skeptics has been that it's normal to have changes throughout time, even without the influence of humans. So I'd like to ask you some kind of science fiction question. What would the climate be like if there was no human effect? If we didn't have emissions, would it be very stable, or would we also have large changes throughout long periods of time?
What we can do is to go back in time and reconstruct climate change as it happened naturally in the past, and ask all our archives, what was the change in the atmospheric temperature? What was the change in snow cover? What was the change in ocean acidification? Etc. And these archives tell us a very clear story. Over the past 800,000 years, we had the waxing and waning of the Greenland and Antarctic and Northern Hemispheric ice sheets, which characterized the come and go of the ice ages on a pace of about 100,000 years. But we also had natural climate variations superimposed on these large glacial cycles of much smaller amplitude. And that's what we would expect to continue in the future. In fact, that continues in the future.
I see.
But it's now overprinted by changes that are of equal, if not bigger amplitude. We're looking at a warming in the business as usual scenario of more than 4 degrees Celsius in the global mean, which is on the same order of magnitude as a glacial, interglacial climate change.
In what period
Only
of
that
time?
it goes to the warming.
Yeah, but in what period of time do you talk about the 4 degrees change?
Well, we are talking over the next 90 years. Much, much shorter than, for example, the warming from a cold ice age to a stable, warm climate that we have enjoyed in the last 10,000 years would have taken. That usually takes about 10,000 years. We're talking now about a time frame that is 100 times faster than what nature has provided us with.
Assuming that we keep the same rate of emissions as we have today?
That's right. That's under the business as usual scenario, which has as a consequence unchecked climate change.
What would be the consequence of that very bad change of 4 degrees in 90 years? What would the world look like?
According to the climate model simulations carried out by 25 centers around the world, it will be a very fundamentally different world. It will be a world that in the global mean is 4 or even 5 degrees warmer than today, with temperatures as high as 9 to 11 degrees warmer than today in the Arctic, with an ocean that is heating up, with snow cover that recedes, with ice sheets that have lost their mass and therefore contributed to sea level, which is projected to rise by the end of the century somewhere around 1 meter, obviously with the uncertainties associated to it.
It's still a lot, right?
That's a lot if you compare it to what we have experienced in the past 100 years. Mankind had to adapt to about 19 centimeters of sea level rise. And in many areas that has already been a challenge. But adapting to 19 centimeters and adapting to another 80 centimeters is a different story. Which means that in many areas, for this unchecked business as usual climate change, we will have reached the limits of adaptation, and that's a big concern.
Both in technical and in, let's say, political terms, like what can be done and what should be done. So my questions are those two. What kind of mitigation scenarios do you envision which are feasible? Because I've read so many things that I don't believe people are thinking about those, but there might be others that should be working. And I want to ask you, what should we do and what are we doing towards mitigation?
One of the most powerful instruments, in my view, that the scientific community has delivered to the policymakers is the global carbon budget. It's the insight and the understanding that all carbon dioxide that has been ever emitted since industrial revolution will determine the warming in the 21st century. So even those quantities that were emitted 50 or 100 years ago, they will have an effect on the warming in the 21st century. So if you now define, and that is a political definition by the countries, a specific climate target, for example, to limit climate change to a warming that does not exceed 2 degrees Celsius, then you can allocate a specific carbon budget to that target, because there is an almost linear relationship between the amount of carbon since industrialization and the warming. What we see for the 2-degree target is that 2/3 of that budget has already been used up, and we are using up the remaining third of that budget at an unprecedented speed, a speed that brings us to the end of this budget in the next 20 to 25 years, given current emission rates worldwide. So it is this instrument that the scientists have given to the policymakers to appreciate the urgency of the problems, but also to appreciate the consequences. What needs to be done to limit climate change is to not more use of that remaining budget than the entire budget. So it's this 1/3 that we have available, and the big question, of course, is how, who, when.
And are you optimistic about it, in personal terms?
I am an optimist by nature, but I'm also optimistic here, provided we will put the necessary measures in place to increase the economic incentives for renewable energies and to remove the incentives, the classic incentives, that are still there but not known to the wider public, of fossil fuel subsidies. And I think by combining that and by a massive technological effort of finding better solution to photovoltaics, to wind systems, to geothermal, and to other forms of renewable energies, I'm optimistic that we will do it. But the scale of the task is that of an industrial revolution.
I see. So my last question has to be, why should we care about climate change? But I want to frame it in a different way. So it's not why should we care about climate change, but can we care about climate change as a species?
I'm not a biologist,
okay.
So I venture here into areas that are outside of my expertise, but I would claim that the seed of caring for the future is innate in our brain. It may be covered by other pleasures and other concerns, but it's in our brain to care for the future. We are part of the biological system, and biological system wouldn't have evolved to the state if they hadn't somewhere built into their system and threaded, hardwired the care for the future, the want to propagate, to evolve, and in some very extreme forms of life, to actually give up your own life for the sake of the next generation. Now, we're not there, but I would claim that even in humans, there is this seed to be able to care for the future. You mentioned the children, absolutely. But we care for even beyond our first generation after us. For example, when you engage in cultural activities where you think, okay, this is something that will last for generations. You build a building or you paint a painting. These are all activities that have in mind also the future that lasts for longer. Now, with climate change, I agree it's a difficult topic because you have to care for the entire globe. But I think with modern science, we are taking a new look at our environment, a look that no generation before us ever had. We have gone to space since the 60s. We have a new view on this planet from outside, which no generation before had. It was the start of, for example, the realization that our resources are limited. Something, of course, everybody has already realized before they went to space. There are good examples of indigenous societies who were keenly aware of the limit of their resources that they disposed of. And I think it's this kind of thinking that needs to come back in our societies. And I hope that science can help to line out where our boundaries are and basically indicate which are the choices today and what consequences are there of our choices today.
That was wonderful. Thank you so much for the interview and also for speaking so praisely about the species, which is all of us. Thanks a lot.
Thank you very much.